All right, let's take a look at the next section in chapter 4. This is on polynomial operations, okay? So most of this should be review. Let's just run through it real quick. I want everybody to do number 1. All right, so if I'm doing number 1, one thing I'm going to establish is these parentheses don't matter at all, okay? They make no difference. So what I'm going to do is I'm just going to go through and search for my like terms, highest exponent to lowest. It's a review on combining like terms. That's all it is. So that'd be 9x squared x terms come next, negative 7x, and then finally regular old numbers. And there's your answer. Everybody go ahead and do number 2. Okay, so when you do number 2, this set of parentheses won't make a difference, but the second set does because of this negative. Now, if you want to think of this as like a -1 that's being distributed, not a bad idea. So what I'm going to do is rewrite this whole problem with that distributive property. So the first part is going to stay the same, but the second part, when I multiply through, see what's happening? All the signs basically change. Now I'm going to go through, search for the highest exponent, combine like terms. See, I'm circling the sign with it as well. 3 minus 5, -2t to the third. Next highest. See, I'm circling the signs. 8 plus 1 would be 9t squared. All right, next term. This is the only t. And then finally, you can see your numbers. And there we go. There's your review of combining like terms. Next thing I'd like everybody to do, go ahead and do those 2 multiplication problems. Let's see if you do those properly. Let's review this. I mean, basically what you have is a FOIL method or a double distributive property. So let's multiply these 2. That'd be 16n squared, right? Then multiply the 4n over here. So that'd be negative 20n. Now take this 5 and multiply. That'd be positive 20n. And then finally, multiply these 2 together. That'd be negative 25. Now take a close look at this problem. You see that the middle terms cancel each other out. Sometimes they do, sometimes they don't. There's your answer. Go down to part B. You can see part C is down there. I want you to do that as well. Let's see how you did on part B. Now, I'm going to get something out of the way right now. This is not true. You cannot do this and say that's 81y squared and then square this and get something like that. That is totally false, because what you've done is you've broken the order of operations. Okay, everyone? And you've actually tried to use a law of exponents that does not exist. If these 2 terms were multiplied inside, you could do that. So don't do that. Some of you are going to try to do it all the time. So here's what you should do. You really need to rewrite this. You should realize that when you square, that means you multiply something by itself. Now you do this problem the same way as the one above. So you should multiply with a double distributive or FOIL method, whatever you want to call this. This is actually going to end up being a perfect square trinomial because you're squaring something. So this will be 81y squared. Combine these together without changing the exponent, and there's your answer. Let's go down to part C. And we got part D down there as well. So if you're feeling pretty good about this, move on to that. Okay, same thing applies here. Do not try to distribute that exponent through here. What this means is this. AB plus 4 multiplied to itself 3 times. So it's not difficult work, but it's time consuming. So here's the way I suggest you do it. When you're multiplying 3 things together, you really start off multiplying a pair of them. So how about we go ahead and knock this out. Now you just got to be careful with your terms. All right, let's go ahead and try this. Let's multiply these two together. That would be a squared b squared, wouldn't it? Next part, ab times 4 would be 4ab. Do this. That's also 4ab. And then finally, 4 times 4 is 16. Now what I'm going to do is simplify that before I move on to the last part, because I see these are like terms. So I'm going to rewrite this. A squared b squared plus 8ab plus 16. Now let's keep in mind that we still have to multiply by that. So I'm going to bring that down here and get that going. Now this is going to be just one gigantic distributive property. 3 of them actually. So I'm going to start off with this. I'm going to multiply this to this. Carefully, add your exponents. A to the third, b to the third, right? Now I'm going to multiply this to the 4. So that'd be 4a squared b squared. Next. Now I'm going to do a distributive property of this 8ab times this. That'd be 8a squared b squared when I add my exponents. And then multiply this to the 4. That'd be 32ab. Okay? And then finally, there's a lot of ways you can set this up. Let me kind of move these over here. Now I need to multiply the 16. So that'd be 16ab and 16 times 4, right? 64, right? Right. Finally, combine like terms. Do we see any other of these? We do not. Okay, I'm going to cross that out. Let's look at these. A squared, b squareds. Yep, here's some right here, right? 8 and 4 is 12. A squared, b squared. Cross those out. How about the regular ABs? 48 of those. And then finally your 64. Okay, it's not a difficult problem, but it is time consuming and a lot of detail to pay attention to. That's one of the objectives in this course, to be able to do that. Now this problem is essentially the same. Now, but what I'm going to do here is show you a different way you could organize your work. Okay? So what I'm going to do is I'll multiply these, and then multiply those. Then what I'm going to do, it's the same thing I did up there. That's 2x squared, right? I'm going to write that under here because they're like terms. I'm just going to organize my work differently. X times 1 is x. Finally, I'm going to multiply by this 5. That's negative 10x. I'm going to put it here because they're like terms, and then minus 5. Then what I'm going to do is treat this like an old-fashioned addition subtraction problem. Just work through these columns. Okay, you don't see anything there, right, to combine with. Add these up. That'd be 6 of those. Add those up. Be minus 9 of those. That comes down. Pretty quick way to do that. Kind of a nice way to organize it. Okay? So there's your review of these types of problems. And I don't think we're even going to worry about doing these. Time for your assignment.